Hi everyone, this is Mrs. Snowbeck. Today we are going to cover Unit 6, Lesson 3, called Resultant Vectors. We've worked a little bit already with resultant vectors, especially when we use the ruler and the protractor. Today it's going to be done more with trigonometry and basic addition and subtraction properties. So at the end, hopefully you can say, I can find the sum of two vectors from drawings, and I can calculate the magnitude and direction of the new vector. Example 1, find the magnitude and direction of the resultant vector. What we're going to do is imagine that this first vector is going off at a 70-degree angle and it has a magnitude of 180. So let me just draw it in blue. Let's just say it goes off like this. This is 70 degrees and 180, just like this little vector over here. And then from the tip of that vector, the next vector is going to take off at a 30-degree angle. So imagine you have like a little origin there again, and it takes off at a 30-degree angle, and it goes 30 degrees for 240, whatever the measurement is, feet, miles, who knows. But this little vector, what our job today is going to be is to figure out what is the magnitude and direction of the resultant vector. So from here, from the tail of the first one to the tip of the second one, this yellow vector, we're going to figure out, well, how long is it? What direction is it going in? In order to do this, we're going to find the components of each of these two original vectors and then add them together to get our new component. That's how we're going to start. So I want you to think about, from this point right here, this would be our horizontal component and our vertical component. And remember, we can use basic SOHCAHTOA to find these measurements. And so if I wanted to find, well, what's the horizontal, or A, on this triangle, this would be a little 90-degree angle. So I could use cosine. I could use adjacent and hypotenuse, and I could go cosine 70 equals A over 180. And I'm going to be able to solve this for A. So I'm going to multiply by 180. These cancel out. I'm going to type that in my calculator, and A is approximately 61.564. Now I'm going to do the same thing for B. So for B, it's going to be opposite and hypotenuse. So I'm going to do sine 70 equals B over 180. Multiply both sides by 180 and type this into my calculator. And when I do that, B is approximately 169.145. And so the component right here at the end of this vector, this would be 61.564, comma, 169.145. Now we're going to do the same thing with the other vector. And so this time, let me just draw it in again. I might have to extend this a bit and get my right triangle. This is A, this is B, our horizontal and vertical components. To find A, I would do adjacent and hypotenuse. So I'm going to do cosine 30 equals A over 240. I set up my little problem here and multiply by 240. Some basic trig. And I type it in my calculator. Make sure your calculator is in degrees because our angle is in degrees. And I get 207.846. Now we'll do the same thing. Let's find B, the vertical component. So this time it's opposite of our angle, so it's going to be opposite in hypotenuse, so sine. So sine of 30 equals B over 240. Multiply both sides by 240. These will cancel out. I type it in my calculator, and B is approximately 120. So our component for this vector is 207.846, comma, 120. Next, we're going to add these together. So I'm going to take my two components, because that's what I'm doing. I'm adding these two vectors together and trying to come up with the resultant vector. So that's exactly what we're going to do here. Now remember, when you add, you're going to take the horizontal components and add them together. And then you're also going to take the vertical components and add together. So if I do 61.564 plus 207.846, I wind up with my new horizontal component, which is 269.410. Now I'll circle them in green. Now I'm going to do the vertical component. So 169.145 plus 120. If I add those together, I get 289.145. So here's a visual of where we're at. This spot right here, if I drew in a right triangle, this horizontal component would be 269.410, and the vertical component would be 289.145. Now, that's nice, but that's not our final goal. What we want to do now is find out the magnitude and direction of that yellow vector or that resultant vector. Well, remember, magnitude can be found with a little formula. I'm just going to scroll up a little here. Magnitude, I'll write it out, equals the square root of a squared plus b squared. This is our new a, this is our new b. So we're going to use this component right here. So here we go. It's going to go magnitude equals big square root of 269.410 squared plus 289.145 squared. And you're just going to type this in your calculator, simplify it down, and the magnitude ends up being 395. Don't forget to take the square root at the end. 395.204. We don't really have a label in this case, so we'll just put an answer around that, but it would be units, whatever the units happen to be. The next thing we want to find is the direction that it's going in. We know the magnitude now, but the direction, I'm going to put a theta in our picture. We want to figure out what is this theta. Well, think about your right triangle. We have, if we look here, if we go across, we have opposite and adjacent. We have these two sides. We have them measured. So opposite and adjacent, that's part of TOA, if you think of SOHCAHTOA. So what we're going to do is we're going to take the tangent of that triangle and we'll be able to solve for theta. So I'm just going to scroll down here again so I have a little bit of work area. I'm going to go tangent theta equals opposite, which is 289.145 over adjacent 269.410. Type it in your calculator. Remember, you're going to have to take inverse tangent to solve this. So these will cancel out, and theta will be the inverse tangent of 289.145 divided by 269.410. When you type that into your calculator, you have to hit second tan, of course, you get 47.024 degrees. So, what is our magnitude? Our magnitude is 395.204 units. What direction is it going? It's going at a direction of 47.024 degrees. So that is into quadrant 1. I'm just going to make a note of that too. It's in quadrant 1. Cool. Example 2. Find the magnitude and direction of the resultant vector. So we want to add these two vectors together and see where it ends up and what is its magnitude and direction. I like to draw out a little visual, so I'm just going to make a little coordinate plane up here. Now the first vector is 120 magnitude and it's heading exactly to the west or left. So it's going to go out this direction. And then the second one, and it's got a magnitude of 120. And then the second one, from the tip of that vector, looks like it's going to head down 42 degrees. And it's going to have a magnitude of 150. And our job now is to figure out from the tail of the first vector to the tip of the next vector, what is this magnitude and direction of that yellow vector? Okay, so we're going to do it just like last time. We're going to start out by finding the horizontal and vertical components, or what is the component of each vector. The first one's kind of interesting because imagine like this is your grid, right? We want to figure out this coordinate. Well, isn't it exactly to the left 120 and exactly up 0? So it's actually going to be negative 120 up 0. So we have it. We have the component. We don't have to do any more SOHCAHTOA or trigonometry to figure that out. Let's go to our other vector. Now our other vector, we're going to say this is our horizontal and this is our vertical component. I label them A and B. And now I am going to have to use SOHCAHTOA to find those values. So if this is our angle, our 42 degrees, A is adjacent to that. So adjacent, and 150 is hypotenuse. So I'm going to use cosine 42 equals A over 150. Just some basic SOHCAHTOA. We had adjacent and hypotenuse. Multiply by 150. And when I do that, A is approximately 111.472. My calculator is in degrees. Next, we are going to find B. And so B is opposite of our 42. So we're going to do opposite and hypotenuse. That will be sine. So sine of 42 equals B over 150. Multiply by 150 on each side. Type it in your calculator. And B is approximately 100.370. But we need to think about where our coordinate is located. Imagine that this is the origin right here. Well, this spot, this point right here would be to the right and down. So our horizontal component is positive 111.472, but our vertical component is down, so it's negative 100.370. So be careful about that. Think about what quadrant is it in. This one would have been in quadrant 4. So our value has to be a positive and a negative. This one over here, it's kind of over between quadrant 2 and 3. Like here's quadrant 2 and here's quadrant 3. And so again, like this spot right here would have been a negative value for that x value. All right, next, remember, we're going to add these two together. So we have to imagine where would it end up. So to add them together, we take our two components and add them together. So we're going to do negative 120, 0 plus 111.472, negative 100.370. And we add the horizontal components first. So I'm going to take the 120 and the 111.472 and add them together. And when I do that, I get negative 8.528. And then I'm going to add the vertical components, 0 and negative 100.370. And that is negative 100.370. So we have our resultant vector. We have the component for that. Remember, how do we find the magnitude? So I'm just going to write this down. This is our resultant vector, so we can kind of keep track. Gets to be a lot of work on the page. Well, remember, to find the magnitude, you're going to take the square root of a squared plus b squared. So we're going to take the square root of negative 8.528 squared plus negative 100.370 squared. When you type these in, remember you have to put parentheses around the negative 8.528 before you square it. Otherwise, it will give you a negative answer, and we want that to end up being positive when it gets squared. And also don't forget to take your square root. So after you type this in, I got positive 100.732. And this, I can call it units if I want. This is the magnitude of our vector. So we know where the resultant vector, what the component is, and now we know its magnitude, like how long it is. Next, we have to find the direction. So think about where this is headed. If you go back to my original drawing up at the top, maybe I can enlarge it here a little bit, we want to figure out what's theta right there. What direction is it going? We just figured out magnitude. We know how long it is. It's 100.732, but we have to figure out its direction. And so think about a right triangle, okay? So I'm going to draw this in. And to draw it in, it's going to look like this. And maybe it's better if I actually just redraw, start from the beginning. So let me draw it in yellow here. Here's our resultant vector. It's going to be over and down, and this would be our right angle. Theta, what we're looking for is this angle right here. Now remember our component. Our resultant component was -8, so this distance is -8.528 to the left. And then it's also, our vertical component was -100.370. We know those two amounts. And so what we can do, since they're distances, we don't really have to think of them in terms of being negative. It won't matter because you're going to they'll end up canceling out anyway, but let's just think of them since they're distances. Let's think of them as positives. And let's see if we can find theta. And so if you think about your two distances, we have opposite and adjacent. This side is opposite, this side is adjacent. And if you think about SOHCAHTOA, opposite and adjacent go with TOA. So I'm going to do tangent theta equals opposite, which was, remember their distances, so we'll just use 100.370 over adjacent, which is 8.528. They're lengths of a side in a triangle. And so when we type that in, we're going to have to do inverse tangent. Inverse tangent will cancel out tangent. Whatever you do to one side, do to the other. And so we have theta equals the inverse tangent of 100.370 divided by 8.528. And when I did that, I got theta equals 85.143 degrees. Now, last thing we have to figure out is which quadrant would that be in? Well, it's 85.143 degrees from the horizontal, and it's down into quadrant 3. So let's just make a note that our theta, or our direction, is 85.143 degrees into quadrant 3, which means down from the horizontal. So let me enlarge this a little bit again. We're going down this way 85 degrees. Number 3, find the magnitude and direction of the resultant vector. So I like to just do a little sketch to start out to kind of give myself an idea of where it should land. The first one is going in a direction of 32 degrees down into quadrant 3. So it's kind of like this. This is, let's say this is 32 degrees and it's going 600. And then from the tip of that vector, the next one, if I imagine like another little origin right there, another little coordinate plane starting from there, the next one has to go 40 degrees, so it's going to go up a little steeper, but only 500. So let's say this is 40 degrees, and this is 500. So it looks to me like the resultant vector is going to start from the tail of this one and go to the tip of this one. It looks to me like it might barely end up in quadrant 2, but we might have to do the math to actually verify that. We'll see. Let's start by finding the horizontal and vertical component of the first vector. So I'm going to draw in a little triangle, and I'm going to call this A and this B, and we're going to do SOHCAHTOA. And so to start, to find A, I have adjacent. This is adjacent. This is hypotenuse. So I'm going to use cosine as usual. Cosine of 32 equals A over 600. multiply by 600. And when I type that in my calculator, I get A is approximately 508.829. Now we're going to find the the vertical component B. So B is opposite, so we're going to use opposite and hypotenuse, which is sine. So sine of 32 is going to be B over 600. Multiply by 600 and type that in your calculator. And I have B is approximately 317.952. So let's write our component and think about what quadrant this would be in. If you think about your origin being right here, I think this is down in quadrant 3. And so I think they're both going to be negative. In this quadrant, your x and your y value would be negative. And so we're going to have negative 508.829, comma, negative 317.952. And that's that vector. Next, let's do our second vector. And so I'm going to draw this in. I'll use red this time. Here's my right angle, my right triangle, and here's my horizontal component and my vertical component. So let's find A first. So if we're using this 40-degree angle, we're going to do cosine 40 equals A over 500, adjacent over hypotenuse. Multiply by 500. Type it in your calculator, and it's approximately 383.022. Then let's find our vertical component. So now we have opposite and hypotenuse. Sine 40 equals B over 500 times 500, and 500 times sine 40, B is approximately 321.394. Think about what quadrant we're in. If this is our origin right here, it looks like we are up here in quadrant 2. And in quadrant 2, it would be a negative x value, positive y value. So when I write my coordinate, it's going to be negative 383.022, comma, positive 321.394. Bam! We have our two vectors. We have their components. So now we want to add those together so we get our resultant vector. So to add them, I'm just going to use them right here, and I'm going to add my x values, or my horizontal components. So if I add negative 508.829 plus negative 383.022, this is going to be a big number, but it's going to be negative, let's see here, 891.851. Negative plus negative will be even more negative. All right, and then negative 317.952. So now we're going to move on to these two I just circled in green. We're going to add our vertical components. And when we add those, we actually get 3.442. And this is our resultant vector. So I'm just going to put a big box around that because that's important. Now, let's kind of look at our picture. Negative 891. So imagine this picture right up here going left 891 and then up 3.42. Yeah, it is barely going to be up there in quadrant 2, I think. It's going to be a positive, so up 3.4. So yeah, our picture looks pretty accurate. Now let's find the magnitude. So to find the magnitude, remember there's a little formula, and it's the square root of a squared plus b squared. And so we take our resultant vector, we do a big square root, and we're going to go negative 891.851 squared plus 3.442 squared. And then we're going to take the square root of that. Go ahead and type all of that into your calculator. I'll just write out, I got 795,410.054 under the square root. And then after I took the square root of that, I got 891.858. And its units. We don't know what the units are, but that would be its magnitude. So the length of this guy up here is 891.858. It seems like that would make sense, right? Because we have a 600 and a 500. Looks like it would be longer than those. I always like to see if it kind of makes sense. Next, we need to figure out the direction that this vector is going in. Now, we're only working with the yellow vector. So if I extend this, it's going to be this tiny little angle. Let me bring that in a little bit. This tiny little angle is what we're looking for. So I'm going to redraw our picture. I think it'll be easier. Our vector is going off like this, right? We're going to try to find theta, and we know some of our values. Remember how this was negative 891.851, and then it was up 3.442? Well, now we can use SOHCAHTOA and we can solve for theta. We can do an inverse tangent here. We have opposite, this side is opposite, and this side is adjacent. So it's part of TOA. So I'm going to go down over here on the right. So I have tangent theta, and opposite is 3.442 over adjacent, which is 891.851. Now remember, we don't really want to include the negative, although that's where it is on the coordinate plane. When you're just thinking about the lengths of the sides of a triangle, you're using the positive amount. So instead of negative there, I'm just going to leave it positive. Solve this by taking the inverse tangent. Whatever you do to one side of your equation, do to the other. Those cancel. And now I'm going to have to type in inverse tangent of 3.442 over 891.851. Type, type, type. It's a very small angle. You might feel like you're getting it wrong. It's 0.221 degrees. It's less than 1 degree. And what quadrant is it in? It's up there in quadrant 2. And that is our direction. So magnitude 891.858, direction 0.221 of a degree into quadrant 2. Nice. That's it. Hopefully you can say I can find the sum of two vectors from drawings, and I can calculate the magnitude and direction of the new vector. Next, you guys are going to work on Unit 6, Practice 3. If you need help, just send us a message and we'll be happy to help. Have a great day.